Okay, so the first thing we're going to learn about light is how does light move? And light moves as a wave. And we've learnt that there are two types of waves. There are longitudinal waves which is how sound moves. And longitudinal waves are formed when particles move back and forwards. Back and forth. Because remember, sound is created by objects vibrating. Vibrations which push the particles in the air or in an object, and so the wave moves along through the air as the particles vibrate backwards and forwards. But light moves in a different kind of wave, which is called a transverse wave. Transverse wave. And transverse means up and down. So if we picture what a light wave looks like, it moves up and down as it goes along. So we can see that the light goes up and down as it flies through the air or through an object. So light overall, we can say it's a type of energy because it can travel through space. And it's not an actual particle, and it's not particles vibrating, which is what a sound wave is. So light can travel through space, and that means light doesn't need a medium, or it doesn't need a material to pass through. It can pass through empty space. Just like sunlight, from the sun, it passes through space until it hits the earth. But even though light travels in a transverse wave up and down, it still moves overall in a straight line. So we can see if the light starts here, overall it still moves in this direction. And if we have a torch and we turn it on, the rays of light will move in a straight line out from the globe. Just like how we draw a sun. The rays of the sun, so the light waves, move out in a straight line from the object that's creating the light. So now we'll look at some more detail about the features of a light wave. So again, here is our transverse wave of light moving up and down as it moves along. And we'll draw a middle line that's halfway up the light wave. And we can also label the top and the bottom of the light wave as the peaks and the troughs. Peak means the top and trough means the bottom. So in this light wave we have 3 troughs and 3 peaks. And just like every wave, we can measure the wavelength. So in this light wave, the wavelength can be the distance between two peaks, that distance there, wavelength, or we could measure between two troughs. That will also give the wavelength. And we use the symbol, the Greek letter lambda, to represent wavelength. The other feature that we can measure about light waves is the amplitude. And amplitude measures the height from the halfway line up to the top, or the halfway line down to the bottom or the trough of the wave. Both of these are the same distance. Amplitude or amplitude. And the amplitude of a light wave tells us the brightness. How bright is that light wave that we can see? And the wavelength determines what color is that light. So if we look at two example light waves, if we have a light wave with a small amplitude, we can see the amplitude here from halfway to the peak is really small. And then we compare that to a light wave with a bigger amplitude from halfway to the top. That first light will have a low brightness, so it will be very dim. And the second light will be much brighter.